On June 7, 1984, atmospheric conditions across the Central Plains states entered a configuration common to late spring. A low-pressure system moving northeast from the Rockies, warm, moist air from the Gulf of Mexico, and a dry upper-level jet stream from the west. Kansas, Nebraska, Oklahoma, and Iowa operated under normal agricultural and municipal schedules. Power grids carried standard loads. Highway traffic followed weekday patterns. The National Weather Service Severe Local Storms Unit in Kansas City monitored developing instability parameters. Surface temperatures reached the mid-80s Fahrenheit by early afternoon. Dew points climbed into the upper 60s. Wind shear values increased as directional variance between surface and upper-level flows exceeded forecast models. By 1400 hours Central Daylight Time, convective available potential energy measurements exceeded 3,000 joules per kilogram across a 200-mile corridor. The Central Plains topography consists of gently rolling terrain between the 97th and 100th meridians, elevations ranging from 800 to 2,000 feet above sea level. Agricultural land use dominates: wheat, corn, and cattle operations. Population centers include Omaha, Nebraska, Topeka and Wichita, Kansas, and Oklahoma City, Oklahoma. Smaller municipalities serve as county seats and agricultural processing hubs. Spring weather patterns typically feature southerly surface winds, occasional thunderstorm activity, and temperature fluctuations. Tornado occurrence is historically frequent but geographically dispersed. Infrastructure design standards account for high winds, but prioritize cost efficiency over extreme event resilience. Housing stock consists primarily of wood frame construction with limited reinforced shelters. Power transmission relies on above-ground lines supported by wooden and steel poles. Interstate highways, state routes, and rural roads form transportation networks with minimal grade separation. Emergency services operate from county-level dispatch centers with radio communication systems. The regional economy depends on continuous agricultural processing, livestock transport, and grain storage operations. Weather forecasting capabilities in 1984 included satellite imagery, radiosonde data, and surface observation networks. Warning lead times for severe weather averaged 10 to 15 minutes. Public alert systems used sirens, radio broadcasts, and television interruptions. Seasonal preparedness focused on hail protection for crops and livestock shelter. Institutional memory of significant tornado outbreaks informed, but did not dictate operational procedures. The morning of June 7 began with agricultural fieldwork, school operations, and commercial activity proceeding normally. No elevated threat messaging preceded midday. Atmospheric data indicated potential for severe thunderstorms, a routine classification for the region and season. Infrastructure operated at baseline capacity with standard maintenance schedules. Meteorological analysis of June 7, 1984 conditions shows a classic supercell environment. A surface low-pressure system positioned over western Kansas generated southerly winds at 20 to 30 miles per hour. A dry line extended from the low southward into the Texas Panhandle, separating moist Gulf air from dry continental air. Upper-level winds from 300 to 500 millibars flowed from the southwest at 60 to 80 knots, creating strong directional shear. A capping inversion layer at approximately 850 millibars suppressed convection until heating destabilized the atmosphere. By 1300 hours, surface temperatures reached 84 to 88 degrees Fahrenheit across Kansas and Nebraska. Dew points measured 66 to 70 degrees Fahrenheit, yielding lifted indices between -8 and. Helicity values, indicating rotational potential, exceeded 400 meters squared per second squared. Radar installations detected initial convective towers near the Kansas-Nebraska border at 1345 hours. Cell development intensified rapidly as updrafts breached the cap. Reflectivity values climbed above 60 decibels, indicating large hail formation. Velocity data showed mesocyclonic rotation signatures by 1410 hours. Multiple cells developed along a southwest to northeast line spanning 150 miles. Storm motion tracked northeast at 40 to 50 miles per hour, faster than typical for the region. Environmental wind shear profiles supported both supercell maintenance and tornado genesis. The National Weather Service issued severe thunderstorm warnings at 1425 hours. Tornado warnings followed at 1442 hours as rotation intensified. Atmospheric instability remained unchecked. No frontal boundary or outflow-dominated process interrupted supercell longevity. Successive cells developed in similar environmental conditions, creating a multi-hour outbreak scenario. Forecast models available in 1984 lacked the resolution to predict specific tornado tracks or intensity. Observational data confirmed conditions favorable for significant tornadoes, but could not quantify maximum wind speeds or path lengths in advance. The Central Plains infrastructure exposed to the June 7 event included 4.2 million residents distributed across urban centers and rural areas. Housing density varied. Urban neighborhoods contained 800 to 2,000 structures per square mile. Rural townships averaged 15 to 50 structures per square mile. Construction standards reflected regional norms. Wood frame single-family homes, mobile homes in designated parks, brick commercial buildings, and steel agricultural facilities. Above-ground utilities served the entire affected region. Electric transmission lines operated at voltages from 7,200 to 345,000 volts, supported by poles spaced 150 to 300 feet apart. Natural gas distribution used underground mains with above-ground metering stations. Water systems relied on elevated storage tanks and buried pipe networks. Communication infrastructure included landline telephone exchanges, radio transmission towers, and early cellular networks with limited coverage. Transportation corridors crossed the outbreak zone. Interstate 70 through Kansas, Interstate 80 through Nebraska, U.S. Highways 75, 77, and 81, and state routes connecting county seats. Railway lines transported grain and freight on schedules coordinated with agricultural cycles. Airports in Omaha, Topeka, and Wichita handled commercial traffic. Agricultural processing facilities operated near production zones. Grain elevators, meatpacking plants, feed mills, and equipment dealerships. Livestock populations exceeded 2 million cattle and 500,000 hogs in the affected counties. Schools, hospitals, and government buildings provided community services. Emergency shelters existed, but capacity limitations meant most residents depended on residential basements or interior rooms. Warning dissemination relied on outdoor sirens with effective radii of 1 to 2 miles in urban areas, less in rural zones. Radio and television required powered receivers. The population's afternoon distribution included workers in fields and facilities, students in schools, shoppers in commercial districts, and residents in homes. No large-scale evacuations preceded tornado formation. Infrastructure vulnerability stemmed from material limits. Wood splinters under lateral wind loads above 150 miles per hour, unreinforced masonry collapses at similar thresholds, and vehicles overturn at 100 miles per hour. The first tornado touched down at 1458 hours near Belleville, Kansas. Initial funnel formation occurred within a supercell's rotating updraft as rear-flank downdraft air wrapped around the mesocyclone. Ground contact produced a debris cloud visible on radar as a debris ball signature. The tornado tracked northeast at 45 miles per hour, width estimated at 400 yards. Damage surveys later classified intensity as F3 on the Fujita scale, indicating wind speeds between 158 and 206 miles per hour. The tornado remained on the ground for 47 miles, crossing Republic and Washington counties. Structural damage followed predictable patterns. complete destruction of wood frame homes, collapse of unreinforced walls, debarking of trees, and projection of debris at high velocity. A second tornado formed at 15:17 hours near Clay Center, Kansas, from the same supercell system. This tornado exhibited F4 characteristics, wind speeds estimated at 207 to 260 miles per hour, path width exceeding 800 yards, and continuous ground contact for 68 miles. The tornado crossed U.S. Highway 24 and severed electric transmission lines, causing immediate power loss to 12,000 customers. Additional tornadoes developed from subsequent supercells. By 1600 hours, 6 tornadoes were simultaneously on the ground across Kansas and Nebraska. The longest-track tornado formed at 1542 hours near Concordia, Kansas, maintaining F4 intensity for 82 miles before dissipating near Fairbury, Nebraska, at 1734 hours. This tornado crossed Interstate 80, overturning 14 semi-trucks and destroying a truck stop facility. Peak width reached 1,200 yards. Damage included complete foundation sweeping of multiple homes, indicating wind speeds at the upper end of F4 classification. Between 1458 and 1830 hours, the outbreak produced 14 confirmed tornadoes rated F2 or higher. 3 reached F4 intensity. Combined path length exceeded 400 miles. The tornadoes moved at forward speeds of 40 to 55 miles per hour, reducing available warning time. Doppler radar limitations in 1984 meant tornado detection relied on Hooke echo signatures and spotter reports, rather than direct velocity measurements of rotation. Power transmission infrastructure failed across the outbreak zone as tornadoes severed lines and toppled support structures. The first outage occurred at 15:19 hours when the Clay Center tornado crossed a 69 kilovolt transmission corridor, disconnecting substations serving 18,000 customers. Subsequent tornadoes downed additional lines, cascading failures through interconnected grid segments. By 1700 hours, approximately 85,000 customers lost electric service across 9 counties. Emergency generators at hospitals and water treatment facilities activated automatically, but fuel reserves limited operational duration to 24 to 72 hours depending on capacity. Communication systems degraded simultaneously. Above-ground telephone lines broke under falling debris and direct wind loading. The Concordia Telephone Exchange lost commercial power at 1548 hours. Backup battery systems provided limited service for 2 hours before depletion. Radio transmission towers near Belleville and Fairbury sustained structural damage, reducing broadcast coverage. Emergency services dispatch centers experienced call volume surges exceeding system capacity. The Republic County Sheriff's Office received 127 calls between 1500 and 1530 hours, overwhelming 3-line capacity. Emergency medical services faced simultaneous demands across geographically dispersed impact zones. Ambulance response times increased due to road blockages, fallen trees, debris fields, and damaged bridges. The Washington County EMS deployed all 6 units by 1545 hours, exhausting immediate response capability. Mutual aid requests went to adjacent counties, extending transport times. Fire departments responded to structure fires ignited by electrical faults and ruptured gas lines. Water pressure dropped in areas where power loss affected pumping stations, complicating firefighting operations. Transportation networks suffered extensive blockage. Interstate 80 closed between exits 300 and 320 due to debris and overturned vehicles. U.S. Highway 24 became impassable near Clay Center, where the F4 tornado destroyed a railroad overpass. Rural roads experienced blockages from downed trees and utility poles at rates exceeding clearance capacity. Agricultural operations ceased. Livestock scattered from damaged confinement facilities, complicating animal welfare response. Grain elevators lost power, halting loading operations during peak harvest preparation. The cascading failures created resource allocation challenges. Limited personnel, equipment, and communication capability distributed across simultaneous incidents spanning 150 miles. The June 7, 1984 Central Plains outbreak affected approximately 125,000 residents across direct impact zones and adjacent areas experiencing secondary system failures. Casualty counts compiled over 48 hours documented 11 fatalities and 183 injuries requiring medical attention. Fatalities occurred in 3 categories: 5 in residential structures, 4 in vehicles, and 2 in agricultural buildings. The highest concentration occurred in Washington County, Kansas, where the F4 tornado struck a rural community of 38 homes, destroying 22 completely and damaging 14 severely. 3 fatalities resulted from structural collapse. Injury mechanisms included blunt trauma from debris, lacerations from glass and metal fragments, and crush injuries from collapsed walls. The most severely injured required air transport to Level 1 trauma centers in Wichita and Omaha, a process complicated by weather conditions and airspace restrictions during active tornado warnings. Ground transport averaged 47 minutes to definitive care facilities. Housing loss totaled 416 structures completely destroyed and 1,094 sustaining major damage requiring reconstruction. An additional 2,700 structures received minor to moderate damage. Mobile homes experienced catastrophic failure rates. 87% of mobile homes in tornado paths were destroyed compared to 34% of traditional wood frame homes. Immediate homelessness affected approximately 1,800 individuals. Emergency shelters opened in schools and community centers in Concordia, Belleville, Clay Center, and Fairbury, reaching 72% capacity by midnight June 7. The American Red Cross established disaster relief operations in 6 locations. Evacuation orders issued post-event covered areas with gas leaks and unstable structures, affecting an additional 400 residents. Agricultural losses included livestock fatalities estimated at 1,200 cattle and 340 hogs, destroyed grain storage facilities representing 2.3 million bushels of capacity, and damaged farm equipment valued at approximately $4.7 million. Lost agricultural production for the growing season affected 47 farming operations. Economic impact assessments conducted over subsequent months calculated direct property damage at $108 million, $1,984, with indirect losses from business interruption adding $23 million. Insurance claim processing identified coverage gaps. 38% of damaged agricultural structures carried insufficient coverage for replacement costs. The outbreak displaced normal municipal operations for periods ranging from 3 days in minimally affected jurisdictions to 6 weeks in heavily impacted areas. Damage assessment teams from the National Weather Service deployed June 8, conducting aerial and ground surveys of tornado paths. Survey methodology followed Fujita scale criteria based on damage indicators, structural failure patterns, debarking extent on trees, vehicle displacement, and ground scouring. The longest track tornado received an F4 rating based on foundation sweeping of well-constructed homes and complete destruction of commercial buildings. Path surveys measured tornado widths using debris field extent and structural damage swaths. The Concordia tornado's maximum width of 1,200 yards ranked among the widest documented in Kansas history to that date. Total confirmed tornadoes numbered 14, with intensity distribution: 2 F4, 5 F3, 4 F2, and 3 F1. Combined path length reached 423 miles. The outbreak duration of 3.5 hours classified it as a significant multi-tornado event. Federal disaster declarations came June 12, covering 9 counties across Kansas and Nebraska. This designation enabled Federal Emergency Management Agency assistance programs, Small Business Administration loans, and agricultural relief measures. Immediate federal aid totaled $18.3 million for debris removal, infrastructure repair, and temporary housing. Infrastructure restoration proceeded in phases. Electric service returned to 60% of affected customers within 48 hours, 85% within 1 week, and full restoration required 18 days due to transmission tower replacements. Communication systems restoration lagged power recovery due to specialized equipment requirements. Full telephone service resumed June 28. Transportation corridor clearance prioritized Interstate 80 and major highways, achieving passability for emergency vehicles within 36 hours. Complete road repairs extended through August. Building reconstruction timelines varied by damage extent and insurance processing rates. Temporary housing solutions included FEMA trailers deployed beginning June 20, with 147 units installed across affected counties. Permanent reconstruction of destroyed homes averaged 14 months from loss to reoccupancy. Commercial and agricultural facilities followed similar timelines constrained by construction capacity and materials availability. Institutional documentation archived meteorological data, damage surveys, and emergency response analyses. The National Weather Service published a comprehensive outbreak summary in November 1984. Academic studies examined supercell dynamics and tornado formation processes. The event informed subsequent severe weather forecasting improvements and emergency management protocols, though operational changes emerged gradually over following years rather than immediately.